Ladies and gentlemen, my name's Paul, and in this RedGamingTech.com video, we're going to be discussing, as well as analysing tech news, which as usual has popped up in the past 24 or so hours. Hopefully, you are having an amazing day. We have lots of news to get through in this particular video, and I would like to start things out with Intel's Ponte Vecchio, which is a 7nm GPU, which is being designed by Intel for a plethora of different usages. Yes, it will of course be for gaming, but it will also be designed, at least in the higher echelons of performance, for enterprise class GPU performance. This is, of course, to stand them in good stead in GPU computing anyway against Nvidia and also AMD, especially because AMD themselves are ramping up GPU efforts in the data center with their CDNA architecture, and of course we've discussed that quite extensively in the past. Anyway, there has been a very interesting discovery by Momomo on Twitter. I'll link, of course, his tweet in the description of this video. And he has discovered numerous AIC, or add-in card, boards which have been sent via the EEC. Now, this is quite interesting. AIC, add-in card, just so that we're clear, means pretty much the same form factor that you would see if you bought like an RTX 2060 or something like that. In other words, it's a standard discrete GPU. So this is very different to what you would get from a really early engineering sample kind of test board, and it does mean that Intel are, of course, slowly getting closer and closer to release. Unfortunately, a lot of details for their Xe architecture haven't been made public yet. I do know that there were some disclosures at GDC 2020, but obviously we all know how that's kind of worked, and some things have still not been made public. I spoke to a couple of people at Intel, and they have said that eventually they will make some of this stuff public, but they're just not quite ready to do so yet because NDAs are still in place and yada yada yada. But what is really interesting about this particular line of processors is that it seems to be rather different from other approaches. It looks like it's almost kind of a chiplet-based design. I've discussed this several times before, so I'll go over it just briefly here, but basically tiles comprise the actual architecture. Just to be clear, a tile, chiplet, same thing in this particular instance. And obviously you can bolt several of those together to create the performance that you desire. So, for example, a lower end gaming GPU may just have one tile, and then a higher end gaming class GPU would have two tiles, and a server class GPU would have perhaps four tiles. And this can put out a monstrous amount of performance. Former AMD head, Raja Koduri, well, at least he was for Radeon, Raja Koduri actually referred to the Xe class GPUs as the father of all GPUs, which is somewhat of an ambitious statement, to put it mildly. Of course, in the data center, things will behave a little bit differently, because while on desktop graphics, Crossfire/SLI or MGPUs are not exactly as popular as they were, say, back 5 or 6 years ago, in the data center, chaining several GPUs together is becoming extremely important, and therefore Intel are going to be leveraging CXL, or Compute Express Link, and this is all tied together with their One API stack. If anything, I would say that One API is probably one of the cooler things that Intel are working on at the moment. It's a software solution, and it basically obfuscates a lot of the work necessary for programming workloads on taking full advantage of CPU and GPU, and it just makes development really easy and cool. Of course, then again, Nvidia have quite the stranglehold on the market with the CUDA programming language. I think it's going to take a while to know how Intel's offerings actually really bear fruit, because I'm hearing kind of mixed things. I'm hearing everything from that they are actually nailing the performance targets and they're coming on really well, all the way to that they're kind of a mixed bag and they're not quite hitting the performance targets, and they may actually end up being either power hungry or just disappointing. Although one thing that seems to be consistent is that Intel are not going for bleeding edge for gaming first of all. They are not looking to necessarily take the gaming crown for the first generation. Instead, they want to kind of play it more safe, but put out price competitive GPUs. And now we're going to move on to some PlayStation 5 stuff. I actually have lost to count the number of people who have sent me the following story, as well as some Xbox related stuff. So thank you very much to everyone who DM'd me, emailed me, tagged me, and so on. It's extremely appreciated. But let's focus on this particular patent, as it is getting a lot of people confused exactly what it could mean. Now, I'll stress a few things before we begin. The first is that, well, this patent is pretty darn ambiguous, and there are a couple of questions that it leaves unanswered, and I'll get into what those are in just a moment. And the second is that a patent is a patent. It is not necessarily a product or part of a product that is ever made. So Sony could go with an entirely different cooling solution. Indeed, if you watch Sony's Road to PlayStation 5 event, Mark Cerny did say that people would be very pleased with the engineering efforts that is the PlayStation 5's cooling solution, but they would reveal the cooling solution at a later date in a teardown. And they had also said, of course, because the console operates in finite envelopes of power and stuff like that, they know exactly how much heat output the console can create in a maximum capacity. It means cooling it is a lot more of an exact science. Anyway, so if we have a look at the figure here, we can see that 10 is a reference to the actual circuit board layer, the PCB. Whereas 5, which is obviously slightly above that, is, well, the actual APU, the actual silicon die. Meanwhile, 21 is a reference to the actual heatsink itself. Now, I'm sure most of you know this, but I'm going to quickly repeat it. A heatsink's job is to extract heat, hence the term, from a particular component. And obviously, the more efficient the heatsink is, the better the transfer of heat, the more cooling that it can provide to a particular component. And obviously, in the case of the PlayStation 5, because of how the boost frequencies work, there are a lot of different ways that the APU functions compared to, let's say, a more traditional APU, like in, let's say, the PlayStation 4, for the sake of argument. With that said, though, the actual capacity of heat seems to be finite, so in other words, it's not going to vary anymore, and therefore it's more of a power constraint rather than actual heat, which is kind of the main, I guess you could say, variable. So anyway, when we are looking at this particular diagram, there are a couple of questions. The first is, can you kind of sandwich the chip with a second cooler which may appear on top of it? So at the moment, the cooler is basically underneath the board. So the chip is on top with basically a thin plate, and then underneath that is the cooling solution, which essentially allows you to configure things a little bit differently. Normally, obviously things are the reverse. The cooler will sit on top of the board, whereas this is basically flipping things round. Another question I have is, does this also mean that heat can be extracted from underneath the chip? Typically, in most designs, that's not really a big deal. Extracting heat from below the chip is, well, it's not the biggest surface that produces the temperature. Generally, it's on top. But given we don't really know so much about the design of the PlayStation 5's APU, well, I do wonder how that's going to impact things. And another question, what about cooling things like memory and other like components? Is that another reason that the heatsink is in this position? This is pure speculation on my part. I am, unfortunately, not with a final photo of the PlayStation 5's innards to be able to kind of say this with any degree of certainty. But it seems to me that there's a reason that they're doing this, and obviously flexibility of design is one of them. So I do wonder if the bottom heatsink, yes, helps to extract heat from this particular component, the APU, but it also may do other things as well. But, as I said, I don't know that for certain, so I would take that with a huge grain of salt. I don't believe the PlayStation 5 has a heating problem, as I've said numerous times in the past, but I do believe that the design of the console is a little different to perhaps what you would generally associate with a console. I'm hearing it's rather different and unique, but different and unique doesn't necessarily mean good, but everything I'm hearing, the PS5 is pretty awesome. I'm very curious about this console, not just from the performance and the game side of things, but I would really love to sit down with Mark Cerny, and to be honest, I'd really love to sit down with Phil Spencer as well and just like talk to them. Not even like from an interview, just from a pure geek perspective, and just kind of like pick their brains of why they've made certain decisions. From my perspective, I always like to know why a decision's made rather than how a decision was made. So I think the why to me is always a lot more interesting, especially the road not taken, because obviously there's always 1,000 ways you didn't end up building or designing a console. So I'm just really interested to see how all of this turns out. Unfortunately, I could do a deeper dive on the cooling solution, but I think there's just so many aspects to this that we can't be 100% certain of. And I could make some predictions, like once again, I could say that perhaps it's sandwiching the cooling solution and it does leave room for another cooler on top. But ultimately, I am just purely guessing there. So I will just simply say in this video, it's very interesting what they've come up with, and I'm extremely looking forward to seeing the final teardown of the retail console. And now let's move over to the Xbox Series X and a fascinating article from Windows Central. I'll of course link it in the video description. Windows Central have managed to get some opinions of developers regarding the Xbox Series X and what they think of it. I would preface this by saying a few things. Firstly, these are statements that they're making that do not break NDA, so a lot of the nitty-gritty that I would really love to know, unfortunately, is not repeated here. And the second is that a lot of the developers who are commenting are associated with Microsoft. For example, we have someone from the Coalition. Now, that doesn't actually invalidate their opinions of stuff, and it's good to hear what they're saying from the other generation, but you cannot use this article to compare against the PlayStation 5 because it would just not be realistic at all, because they're not comparing anything. At best, you can use it to kind of figure out what this generation has over the previous generation, I would say. But there are still a couple of nuggets here that I find rather interesting. The first of which is from Jason Ronald, who is the lead program manager over at Xbox. And he did provide some insights into the next generation Series X. He said that a lot of the foundation came from the Xbox Velocity architecture, and he basically reminded us that, of course, Velocity architecture is a custom-designed NVMe SSD, and there is a dedicated hardware decompression block on the APU itself. And there is a dedicated hardware decompression block on the APU itself, and this is with a new API, and that is direct storage. But perhaps most critically of all is a sampler feedback streaming solution, as it acts as a multiplier of sorts with physical memory to the console. The Xbox Velocity architecture, according to him, was designed with the ultimate solution of game asset streaming, delivering a level of performance well beyond the raw specifications of the hardware, allowing developers to virtually eliminate loading times and enable them to deliver even larger and more immersive, dynamic, living worlds for gamers to enjoy. I'll get more into that in just a moment. I kind of want to touch on a few comments from each of the developers, and then we can mosey on into it deeper. But Hinterland Games create the survival game Long Dark, which I'm still yet to actually play. Hearing it's really fun though. But here the studio are once again saying that the SSD is really awesome, but ray tracing is going to be incredibly important for the next generation console. He says that I see a potential uses for games like Long Dark, and I want you to listen to this very carefully, where we would be able to simulate physically accurate weather and wind by sending some rays into the world and then having the audio and physics change dynamically based on the snow which is accumulating or melting and that sort of thing. Well, really immersive experiences that just weren't easily achievable before. That's a very interesting statement. Now, of course, ray traced audio, we already know is a thing here, but it looks like a lot of the work when they can actually figure out what actually is going to be interacting with what, once again using ray tracing. Of course, we've discussed ray traced audio before. Indeed, I was actually interviewing NVIDIA when we touched on ray traced audio. But to me, this is one of the reasons that ray tracing is so important, because a lot of people just kind of associate it with shinier graphics, prettier looking graphics, and that, of course, is definitely one thing, but it's not the only thing. It will bring a much deeper sense of immersion. Indeed, this was actually echoed by Rebellion, who of course produce games like Sniper Elite. I'm going to read this verbatim. Hardware accelerated ray tracing is a very welcome feature. Not only does it allow us to take players' environments that are more realistic and dynamic, but ray trace hardware can do more than just rendering. For example, we can use incredible things to acoustics to enhance realism, modeling realistic sound occlusion for AI's hearing in real time, which is incredibly useful for creating stealth titles. Indeed, this is obviously out of quote, if you do some googling of like ray traced AI and pathfinding, there's some really cool stuff that is being worked on by developers. And obviously in this respect, what they're essentially saying is that the AI NPCs would have a much better understanding of where you are positionally in the world, which could lead to some very interesting scenarios in pretty much any game. But obviously in their perspective, they're looking at it from a stealth gameplay point of view. So imagine, for example, you're trying to sneak around guards and then you, I don't know, shoot at a particular dude who happens to surprise you. Well, then other guards would have a better understanding of where you are, and of course because the sound would also reverberate and change based upon where you are in the world. So if you're, I don't know, near concrete walls, for example, it's going to sound very different than if you were in the middle of a field. The Coalition also discusses the console, and I actually find some of the things they say perhaps most fascinating. They said that they expect, of course, generational leaps for the CPU, GPU and memory performance, but the Xbox Series X delivers more than just this. And they go on to say that with Gears, they had actually reduced their load times by about 4 times, and this is without code changes. And that to me is very significant, because it basically means that they had no optimization at all. This is just basically the console doing its own thing, and the game was loading 4 times faster, which is absolutely bonkers, because it essentially means that the game has not been even slightly altered to take advantage of any of the real benefits of the SSD. It's basically just kind of brute forcing its way through, and albeit in about the most inefficient manner possible. So those speeds, those load speeds, are not even slightly reflective of what they could really achieve with the system. And indeed, of course, that would also not leverage things such as sampler feedback. I've heavily discussed sampler feedback and the benefits of it, along with numerous other stuff which is related to DirectX 12 Ultimate in, well, a DirectX 12 Ultimate video that I put out maybe about 2 weeks ago, so I'll try to remember to link it in the video description. And I actually do believe that, while of course hardware accelerated ray tracing is pretty damn awesome, there's also a lot of focus, of course, on variable rate shading right now. To me, the two unsung heroes for DirectX 12 Ultimate are A, mesh shading, and B, sampler feedback, because currently the way that games handle MIP levels of textures, just for example, is not exactly the best for either the perspective of the game themselves, games developers themselves, or the game engine. And given, quite frankly, that 16 gigabytes of memory on the next generation consoles isn't that big, I mean, I'm not saying it's titchy, but it could be filled up extremely fast with high resolution textures. So the consoles being able to load in and predict what assets are required efficiently is going to be of critical importance, not just, of course, to get games looking their best, but also to ensure that there's no hitches in terms of performance, because otherwise you're going to start seeing frame rates drop while data's loaded in, or textures pop in, or just it doesn't look quite right because you're really close to a texture and it's still got the lower resolution version, the low MIP level in there, and yeah, you can kind of get where I'm going with this. But anyway, hopefully you have enjoyed the video. The normal stuff if you did, like, share, comment and subscribe, and I will see you soon. Take care of yourselves. Bye for now.